Good morning, everyone. So today we're going to be looking at compound interest. And compound interest is interest that is due at the end of each payment period and then is added to the principal. So that interest computed at the end of the next payment period is going to be based on the new principal amount. So what that means essentially is, so you start with the principal amount, but then the next pay period you've earned interest. And then the next pay period, you're going to earn interest on everything, including that first pay period's interest that you earned. So everything is earning interest as well, including the interest that was previously earned. So just to go over the parts of this equation, P is going to represent the principal, and that's the total amount that is borrowed from the lending institution, the bank. Or you can think of it as the initial amount that it starts as. And then the R is the per annum interest rate, also known as the yearly rate. So I do want to emphasize the word yearly there. And it has to be written as a decimal. Okay, so to write that as a decimal, typically you'll see it as a percentage. So to write it as a decimal, just move the decimal to the left. Okay, and then the A is going to be the future value. So that's going to be the amount of money that it is worth after T years. So T is going to be the number of years. So again, years. And N is going to be the number of compounding periods per year. This is going to be based on the situation you're looking at. So it depends. Are you earning interest monthly? Are you earning interest yearly? How are you earning interest? So N is going to be how many pay periods per year. So again, everything is in terms of year. So if you are annually compounding, well, annually means 1 year. So that means how many pay periods are happening in that 1 year. If it's only compounding annually, that means N is 1. So if you were to plug that into your equation, that would be A equals your principal times the quantity 1 plus R over 1 to the 1 times T. But these ones really don't do anything for your equation. So that can just be written as A equals P times the quantity 1 plus R to the T. Now monthly, well, how many months are going to be in 1 year? Well, that's 12. So N equals 12. So we're going to replace 12 in for N in this equation. So A equals P times 1 plus R over 12 to the 12T. And daily compounding means how many days are in a year? Well, that's going to be 365. So we're going to replace N with 365. So your equation would be A equals P times the quantity 1 plus R over 365 raised to the 365T. All right, so let's try our first problem. We're going to be finding, get this to focus real quick. There it is. Okay, we're going to be finding the amount that results from investing $50 at 6%, where it's being compounded monthly. And we want to figure that amount after a period of 3 years. Okay, so first, $50 is what you are investing. So that's going to be your principal. 6% is your interest rate, your yearly rate. Okay, so 6% has to change into a decimal. So 6, move the decimal 2 to the left. Your R value is going to be 0.06. And it's going to be compounded monthly. So if it's compounded monthly, how many months are in a year? Well, that's 12. So N equals 12. And then after a period of 3 years, that's T. So T equals 3 years. So P was the 50, R is 0.06, N is 12, T is 3. Okay, so let's plug into our equation. A equals principal, which was 50, times the quantity 1 plus our interest rate of 0.06 over N, which is 12, times 12 is N times T of 3. And then you can just type that right into your calculator. You don't need to simplify it. So 50 times 1 plus and a fraction 0.0. Of course, every time. It wants to be projected onto Smart Notebook, but it's not, or a Smart Board, and it doesn't like when I use it on my desktop without this Smart Board attached. Sorry about that, guys. 0.06, 0.06, I typed 0. Okay, divided by 12. Arrow over, close your parenthesis, and then raise it to the exponent, which is 12 times 3, or you can just multiply that yourself if you'd like. But I'm just showing you, you can just type it all in the way you see it. So that ends up being $59.83. So that's going to be how much is in the account after 3 years. Okay. Next, how long will it take for an investment of $12,000 to grow to $1,500? Sorry, $1,200 to grow to $1,500 at a rate of 3% compounded annually. So this time, if they're asking us to find how long it's taking, well, that's T. So we're solving for T. Okay. Now, how long will it take an investment of $1,200 to grow to $1,500? So if the investment is starting at $1,200, that's your principal. What it's growing to is your A value, that's your end amount. The rate is 3%, so that means R is 0.03, and it's compounded annually, so that means N is 1, because it's only earning interest once a year. So now let's go ahead and plug everything into our equation. So again, just to remind you, it's up on top, but A equals P times the quantity 1 plus R over N to the NT. So A is being replaced with 1,500 equals P is replaced with 1,200, 1 plus 0.03 divided by 1, which you really don't need because anything divided by 1 is itself, and then 1 times T. So we could simplify that. 1,500 equals 1,200. 1 plus 0.03 to the T. Now we want to solve for X. It's our exponent, so we need to get the power here all by itself, and we're going to do that by dividing by 1,200 on both sides since it's being multiplied. And when you divide those, it comes out to a nice pretty decimal of 1.25, so I'm going to go ahead and just write it like that. And then you still have 1 plus 0.03, and if you want, you can just simplify that right to 1.03 to the T. And then you can just do log of both sides. You can rewrite this. It doesn't make a difference. We do log or ln, but I'll just do log in this one. So now you have log of 1.25 equals log of 1.03 to the T. But remember that T goes out in front. I'm going to come back up here to finish it. I have log of 1.25 equals T times log of 1.03. Therefore, last step, to get t all by itself, divide both sides by log of 1.03. Divide by log of 1.03. So t equals that fraction. And then you just type that into your calculator. Log of 1.25 divided by log of 1.03. Of course, every time. Try this again. All right, there we go. And you get 7.549. So we'll just call that 7.55. But now we solve for t, and t is number of years. So it'll be 7.55 years for that investment to grow from 1,200 to 1,500. All right, and last but not least, there's one more formula that you need to know, and that's going to be when you have the interest earned being compounded continually. Okay, so that basically just means that you're increasing n to infinity. So it's just going to infinitely many times. So that's going to be this happening infinitely many times. So because of that, we have a different equation, and it's going to be A equals PE to the RT, or perp. People used to remember that. And there's E, which is our constant value, which is the base of our natural logarithm. And again, it's approximately 2.71828 and keeps going. All right, so we're going to use this equation whenever it is being compounded continually. So in this problem, we have, let's see, find the amount A. So we're solving for A. That results from investing a principal P of $1,000 at an annual rate. Annual means N equals 1, right? Okay, so that's not going to affect this equation, but annual rate R of 10% compounded continuously for a time of 1 year. And then we're going to do it for 18 months. So let's do first all that. So we have the P is 1,000. We have R is 10%. So let's write that as 0.1. And the time is 1 year, so t equals 1. And now we're going to plug that into our equation. A equals 1,000 times E to the 0.1 times 1. So 1,000 E to the 0.1 essentially. Type that into your calculator. And you get $1,105.17. Okay. Perfect. And last but not least, we're going to do the same thing, but this time for 18 months. So the only thing that's changing is the amount of time that lapses. So before it was 1 year, now it's 18 months. Well, 18 months is really 1.5 years. So the only difference for part 2 on this equation, this example rather, is that t is now 1.5. But the principal is still going to be that $1,000, and your interest rate is still going to be 0.1. So plug into your equation, 1,000 e to the r 0.1 times t, this time is going to be 1.5. And then let's plug that into our calculators, and we are done. Do I type that in right? Where did I type that in incorrectly? Let's see. Just make sure I type that in right. 1,161.83. So 1,000.1 times 1.5. All right. We are all set. Let me know if you have any questions. Sign up for office hours if you have any questions that I can't answer via email. And good luck on your homework. Let me know how you do. Take care. Bye.